Hello everyone, welcome back to the another session in design and analysis of algorithms. The topic name is parallel algorithms. Introduction. This topic you will find in unit 5 and topic number 6. Now let's get started. What is parallel algorithm? Parallel algorithm, before we go to talk about parallel algorithm, let's talk about what is the algorithm. What is an algorithm? An algorithm is a sequence of steps that takes inputs from the user, and after some computation process it will produce an output. This is what general algorithm definition. How many ways I can write the algorithm? So it depends upon the architecture of computers. Depending upon the architecture of computers, we can write algorithm in two ways. The one way is sequential algorithm. The second way is parallel algorithm. Now let's talk about each. What do you mean by sequential algorithm? That is, the algorithm, an algorithm which some consecutive steps of instructions are executed in a chronological order to solve a problem. Let's take some example to understand what is sequential algorithm. Now this is the problem P, what I wanted to get the solution by executing it. So I am using CPU to execute this problem. So before I take this problem into implementation, I have to write an algorithm. So the algorithm what I am writing, it will be in some number of steps, right? So sequential, the name itself it suggests that the algorithm will get executed sequentially or the chronological order. So this is what actually sequential algorithm is. Now what do you mean by parallel algorithm? That is, when you have a problem P to get solved by using some CPU, you will be dividing this problem into sub-problems, that P1, some P2, some P3, depending upon the length of the problem, we will be dividing all into sub-problems. Now let's see that P1 and P2, P3, P4, we divided all these into sub-problems. Once after you divide all these into sub-problems, now we will be going to execute this simultaneously. That means parallel algorithms are algorithms to be run on parallel machines. A parallel algorithm can be executed simultaneously on many different processing devices and then combined together to get the correct result. That means after you divide this, these will get individually implemented and the solution will finally get combined into one. So this is what actually parallel algorithm means. Now let's talk about principle of parallel algorithm design. On basis of what I can divide the whole problem into sub-problems, how I can do the implementation part or how I can get the output of each sub-block. That is, the first step in developing a parallel algorithm is to decompose the problem into number of tasks. That is, I am decomposing the problem into some number of tasks, and this can be executed concurrently. Now, a given problem may be decomposed into 4 tasks. That means T1, T2, T3, T4 in many different ways. So I am taking here task dependency graph. The meaning of this graph is what? T4 is a sub-problem from P and it is dependent on T2 output, T1 output and T3 output. Now T2 is a sub-problem which is dependent on T1. So first of all we'll execute this T1 and the output will be given to T2 and T3. So these two will get executed concurrently or parallelly we'll execute these two. Then after we'll execute T4. So the reason is here, if the task is dependent upon the other task, till the task completes that task, you cannot pass the output to that particular task to get executed. Correct? So this is what task dependency graph. Now, so here task may be of same, different or intermediate sizes. Whatever task it is being performed by each task, T1, T2, T3, T4, the task may be of same or it is different or it is even indeterminate size. And a decomposition can be illustrated in the form of a directed graph. with nodes corresponding to task and edges, and these edges are indicating that the result of one task is required for processing the next task. Such a graph is called as task dependency graph. Now, so with this you might have understood what is parallel algorithm, how parallel processing will get happened in the CPU. Now we'll see about a simple parallel algorithm. The question is what? I wanted to add these 8 numbers, and if it is a sequential one, we will be adding 5 plus 3, and the result of this will get added here, and the result of this will get added here. Sequentially it happens. So we will be not going to compute this problem using of sequential algorithm. We'll be going to use parallel algorithm. Now how parallel algorithm will be done? Parallel algorithm will get divided, or the work will be, problem will get divided into number of subtasks. So I'm just dividing this thing. I'm just considering all the elements as the vertex or the nodes as we were seen in the task dependency graph. So all these are my t values, t1, t2, t3 something, right? Now the first two elements are added by p1. So here, to get execution of -6 and 2, we need not to depend upon any one. I mean, no task is dependent over here. Every task can happen concurrently or parallelly it can happen. So I am going to use 4 different processors, P1, P2, P3, P4, where each process will take the operation of 2 elements. Now 5 plus 3, 8, -6 plus 2, -4, 7 plus 10, 17, -2, 8, 6. So concurrently or parallelly you did this job, correct? Now again you will be doing the job that P1 process will get the result of 4 here. 8 minus 4 it is 4. 17 minus 6 it is 23 plus 6. 17 plus 6 you will get answer of 23. Now this is what P3 processor. Now P1 plus P3 will get activated to in order to perform the result of 27. P1 plus P3. So this is what, adding of 8 numbers, we start with the 4 processors and each of them adds 2 items in the first step. So this is what you are executing some task using parallel algorithm. Now, so approaches to develop parallel algorithms are, parallel algorithms for a given problem may be developed using one or more of the following. The first is detect and exploit the inherent parallelism available in the existing sequential algorithm. And the next approach is independently invent a new parallel algorithm. Adopt an existing parallel algorithm that solves a similar problem. So this is what the approach to develop a parallel algorithm. Now we'll see how complexity of the algorithm will get calculated. So basically a parallel algorithm is analyzed mainly in terms of its time complexity, processor complexity and work complexity. What is time complexity? Execution time which is required to execute the steps of the algorithm. That means how many steps are needed to complete the algorithm. That is what your time complexity. What do you mean by processor complexity? Total number of processors used and to complete the work. Work complexity is what? It is total cost. The total cost formula is time complexity into number of process used. So this is about to calculate time complexity. Now talk about space complexity. As we were running this problem in different machines, that means we'll be going to have different processors, or in the same processor we'll be going to have concurrent execution. For both the cases we'll not worry about space, because anyhow you are taking multiple processors to get placed off all your parallel algorithm works. Hence the space complexity obviously will be more. So we will not bother about space complexity when the case of parallel algorithm comes into the picture. We bother about only time complexity. What is the time complexity which takes to complete the work is matters a lot. Now we'll talk about a simple parallel algorithm. For adding 8 numbers, we start with 4 processors and each of them adds 2 items in first step. The total number of items are half for every subsequent step. If you see the algorithm, what we were drawn just before, in that algorithm, every step the elements are half, right? Now, the total elements are n. Now that n has divided into half, that means n has divided into n by 2. That means if you apply logarithm on both the sides, hence log n steps are required for adding n numbers. The processor requirement is what? Order of n. Now, the time complexity is order of log n. Processor complexity is order of n. And work complexity is what? Time complexity into number of processors which are used. Time complexity is what? Log n into big O of n. So total complexity is what? N log n. So this is what the complexity which can be calculated for a simple parallel algorithm which we were took in the previous slide. Now let's calculate speed up and efficiency of the same algorithm. Now let's take T star of n be the time complexity of a sequential algorithm to solve a problem P of input size n. And let's consider Tp of n be the time complexity of a parallel algorithm to solve P on parallel computers with the different processors. Now, the formula is what? The performance of a parallel algorithm is determined by calculating its speed up. Speed up formula Sp of n is equal to T star of n by Tp of n, because speed up is calculated with the help of what is the whole number of lines in the algorithm by the dividing into each processor. That is what speed up. That speed up Sp of n less than or is equal to naturally P, the problem. And the best solution is what? Sequential time speed up is equal to P, where Tp of n is equal to T star of n by P. So this is what speed up formula to calculate for a parallel algorithm. And we do have efficiency also. Ep of n, that is parallel algorithm efficiency, is equal to speed up of n by P. That is T1 of n by P into Tp of n, where T of n is when the parallel algorithm run in single processor. If not, naturally we will be calculating efficiency after you calculate the speed up by the number of processors what you divided to execute the parallel algorithm. So this is the way how we have to calculate speed and efficiency for an parallel algorithm. Thank you all.